Good evening, everyone. I am M. Purnima Devi from SNS College of Technology, Department of Artificial Intelligence and Machine Learning. Today I am going to discuss about sentiment classification. Introduction. Sentiment analysis, sometimes known as opinion mining or emotion AI, refers to the use of natural language processing, text analysis, computational linguistics, and biometrics to systematically identify, extract, quantify, and study affective states and subjective information. Sentiment analysis is widely applied to voice of the customer materials such as reviews and survey responses, online and social media, and healthcare materials for applications that range from marketing to customer service to clinical medicine. So, in older days, XCC system consists of mining the sentiment information contained in the massive user generated content can help sense the public's opinions towards various topics such as products, brands, disasters, events, celebrities, and so on, and is useful in many applications. For example, researchers have found that analyzing the sentiments in tweets has the potential to predict variation of stock market prices and presidential election results. So, classifying the sentiments of massive microblog messages is also help to substitute or supplement traditional polling, which is expensive and more time consuming. So, proposed system. So, nowadays, a collaborative multi-domain sentiment classification approach (CMSV) based on multitask learning to train sentiment classifiers for multiple domains simultaneously. We propose to extract domain-specific sentiment knowledge from both labeled or unlabeled samples. We use it to enhance the learning of the domain-specific sentiment classifiers. Besides, we propose to use superior general sentiment knowledge in general purpose sentiment lexicons to guide the learning of the global sentiment classifier. We introduce an accelerated algorithm based on FISTA to solve our model effectively and propose a parallel algorithm based on ADMM to further improve its efficiency. So, here the systematic architecture sentiment classification. So, first of all, training phase. So, all the data are collected into a database. So, from the database, the pre-processing, tokenize the word. So, analyze the word. Then noise word removal. The extra words are removal. The unwanted words, noise were removal from the system, and all the words are clustered together. So, all the words were clustered into differently, and sentiment words were differentiated. So, positive commands are listed into one thing, and negative commands are listed into other things. So, we include some of the domains which is used in this field. For example, in electronics, movies, and also books. So in domain classification, so electronics, movies, books, we analyze some sentiment words. For example, easy, hard, easy, sad, good, bad. So these and all sentiment classification words. And domain classification in negative commands for electronics, movies, books, etc. So here hard, easy, hard, very awkward. So these kinds of words where comes under negative commands. So all the words are clustered into one group. So that is known as clustering, and testing phase is made for every domain classification For example, if the user give the input commands, for example, the product is good or the product is bad, the input components were pre-processing. The pre-processing words collectively taken into the sentiment words. So here the words are splitting together positive and negative words. So positive commands are comes under one domain classification, and negative commands that comes under in one domain classification. So customer commands. Reviews on online product are not only related to the product but also the service given to the customers. If users get clear bifurcation about product reviews and service reviews, it will be easier for them to take the decision. In this paper, we propose a system that performs the classification of customer reviews followed by finding the sentiment of the reviews. The customer gives opinion. Cluster analysis or clustering is the task of grouping a set of objects in such a way that objects in the same group, called a cluster, more similar in some sense or another to each other than to choose in other groups, that is clusters. So in implementation, to handle multiple source domains and multiple target domains, taking the differences of domains into consideration because it is common in sentiment analysis that are various kind of domains. Our model is designed with multiple source and target domains in mind from the outset. All existing studies conduct among different domains. So designing an online product review classification system, we cannot merely collect labeled review data on one product example book to train the classifier because this classifier may perform very badly on some other products, example electronics. So due to the domain specific character of sentiment classification, one way to ameliorate this problem is to construct a lexicon of sentiment bearing words constructed from a wide variety of domains. So conclusion, gaps in the existing approaches and possible future words are suggested according to each of the big data issues. It is predicted that studies and skills development on SA on big data platform for brand monitoring and customer relation management are going to get increasing attention, and its growth will be energized by the high demands and the promise of higher revenues for companies. This prediction is supported by analyzing the current marketing reports, surveys, and summits on SA based big data analytics for application in customer behavior understanding and social network commands analysis for customer sentiments. Thank you.